All right, so this video is going to go over pages 9 and 10 in your waves packet. So we're going to see is when we give you an original wave and ask you to change something, what is the new wave going to look like? So this kind of looks blurry on mine. So number one, you're just going to kind of follow along in your paper. Number one, draw a wave that has twice the amplitude of this one. So amplitude is the height of a wave. So if I want twice the amplitude, I'm going to make it higher. Now, I didn't say anything about making frequency different or wavelength different. So if I look here, if I asked you how many waves were in the first one, there is one wave right there, okay? And then you have another crest right here, so that'd be 1.5 waves. Okay, so that means when I draw my new one, I still want 1.5 waves. It should still start and end in the same spot. Okay, all I want is it to be higher. Okay, so if I'm gonna increase my amplitude, I'm gonna go up to the second notch now. So we're gonna pretend that's the second notch right there because it ended at the first notch on the first one. And we're gonna come back down. We're still gonna cross in the same spot. So if you look on the left one, it crossed right there. So we want it to cross in the same spot there. And we're gonna go all the way down and back up. We still want it to cross in the same spot here. You want that to match on both sides. It doesn't have to be perfect, okay? But if I have 1.5 waves in the first one, I still want 1.5 waves in the end. So I'm gonna go back up, come back down, and I'm gonna end right here. So if you look, still looks like basically the same wave. It's just all I do is make it higher. Okay, so if I want to increase amplitude, you make it taller. And if I want to decrease amplitude, you're just gonna shorten it out or flatten it out. Number two, draw a wave that has twice the frequency of this one. So if I look, this one there's one trough, there's one crest. So all I have is one wave right here. So if I want twice the frequency, that means I want twice the number of waves. Okay, so if I have one wave here, okay, I need 2 waves in my next one. And I need 2 waves by the time I get to that 4th notch, okay? So I'm not gonna draw the same length of wave and just keep going. I need 2 waves now in the same amount of time. So the only way I can do that is by making the wave shorter, okay? I'm not gonna make it go any higher or lower because I didn't say anything about amplitude. So I still want the same height, but we just need to make it shorter. The way I do that is if it took basically 2 notches to get a trough in, just cut it in half. Okay, so that means now it should only take 1 notch to get a trough in, and it should take 1 notch to get a crest in. So now you have 1 wave in half the distance. So all you gotta do is just keep doing this until you get to the end, and now you have 2 waves. So that is what that would look like if you wanted to have twice the frequency, okay, in the same amount of time. All you gotta do is make the wave shorter so you can fit in 2 waves. Number 3, draw a wave that has twice the wavelength of this one. So now if I look in this one, there's 1 wave right there, and then I have 2 waves. So I want twice the wavelength. So what that means is I gotta stretch this out. Okay, I want twice the wavelength, so I gotta make it longer. So that means I'm not gonna be able to fit 2 waves in 4 notches. Okay, so that means I'm only gonna be able to fit 1. Okay, because if I double everything, because here it took only 1 notch to get from, here, let me use a different color. It only took me 1 notch to get a trough here. Okay, so now if I want to double that wavelength, now it's going to take me 2 notches to get 1 trough. And now it's going to take me 2 notches to get 1 crest. Okay, so that would be my new wave right there if I made twice the wavelength. Number 4, draw a wave that has half the frequency of this one. So half the frequency means less waves. So right here, if I have 2 waves here, that means I only need 1 right here. Okay, so didn't say anything about amplitude, so I'm gonna just keep the height the same, but now I've got to stretch this out where I only want 1 wave in that same amount of time. So if you notice, these 2 are basically the same, okay, but there's different ways I could ask it. I could say twice the wavelength or half the frequency. It's the same thing, okay? Number 5, draw a wave that has half the wavelength of this one. So half the wavelength means I'm gonna make it shorter. Okay, so that basically means you can look at it 2 ways. You can make it shorter. So if wavelength goes down by 2, okay, frequency is going to do the opposite. Frequency means it's going to go up by 2. So that means you need to be able to fit 2 waves now in the same amount of time. Either way you want to look at it. You could look at it from a frequency standpoint where I know, well, frequency has to go up by 2. So that means I need 2 waves instead of 1. Or you can just look at it from the wavelength standpoint. I'm like, well, I'm going to decrease everything by half. So if I have 1 wave here, okay, and I want half the wavelength, that means I'm probably gonna be able to fit 2 waves here. Okay, so it's only gonna take me 1 notch for that trough and take me 1 notch for that crest, and then 1 notch for the trough, and then 1 notch for the crest. Okay, that would be half the wavelength. So now you can fit 2 waves in that amount of time. Number 6, draw a wave that has half the amplitude but double the frequency of this one. So half the amplitude, so now I have to actually make this shorter. It was going up to here, but now I'm gonna have to cut that in half. And I wanna double the frequency. Okay, so if I look at this original one right here, there's 1.5 waves there. Okay, there's 1 full crest, 1 full trough, and then only 1 full crest, so it's 1.5. That means this one has to have 3. Okay, so I need to make it shorter. I'm gonna decrease that height, and then I need to fit 3 waves in the same amount of time. Now, it doesn't have to be perfect. Okay, I know this can kind of get hard sometimes, is figuring out where does it cross the line. It does not have to be all perfect. If you can show me that there's 3 waves before that 4th notch, we're good with that. If one looks bigger than the other, that's fine. It's kind of hard to space these things out. Okay, so it should kind of look like this. Is we're going to go up to the 1st notch now because we want to decrease the amplitude. And we're going to come back down and then go back up and then come back down and then go back up, and then we're good. Okay, so there's your 3 waves there. Okay, so again, doesn't have to be perfectly symmetrical or perfect. Okay, but what you did show me here, if you drew it like this or just slightly off, if you still had 3 waves, you're good because you doubled your frequency. If you reduced it to a half, your height to a half, you're good there because you showed me that I wanted half the amplitude. In summary, so half the frequency means the same as double the wavelength. Okay, so there's different ways I can ask it that mean the same thing. So double the frequency means the same as half the wavelength. Okay, so the proper phrase to describe the above answers is to say that frequency and wavelengths are inversely related to each other. Okay, so that means if frequency goes up, wavelength has to go down. Okay, they will never go in the same direction. So why is it impossible to draw a wave that has half the frequency but also half the wavelength? Because they never go the same direction. Okay, if my frequency went down by 1/2, so divide by 2, okay, that means my frequency, this is my frequency. If frequency goes down by 1/2, that means my wavelength, let me clear this up real quick. That means my wavelength's got to do the opposite. Okay, so wavelength's going to go up by 2. So they'll never go in the same direction. They're always opposites of each other. And that'll end that one.